Sometimes it's important to understand what's happening down in the hardware, and then we need to measure how the program interacts with hardware. So this reveals how well the application fits the underlying hardware. In particular, it's useful to find out about cache misses, mispredicted branches, context switches, and so on. And it could be hard to probe and understand, but if you can utilize the information, you can get some huge performance improvements. So let's go through a little bit of information on how to work on it. First, you need to sort of understand how the hardware looks like, and there are ways to find out that. You can ask the operating system or virtualization layers and so on, look in the manuals, use tools like HWLock and so on. If you're on Linux, you can, for instance, have a look at the files CPU info and mem info. That will reveal quite a great deal of information about the processor. There are some special ls commands they can use, and for even more detailed commands, you need root access, and you can these kind of commands here. HWLock is a software tool that will give you sort of a graphical representation of how the hardware looks like. So LSTopo gives the topology of the memory system, and this is what is returned on the computer gothmog, where you can see that. So each square here is a core, and you have is a processor, and you have 6 cores on each processor, and each package you have 2 of these chips, and they are connected. So in each processor you have 12 cores, and then you have 4 of these for a total of 48 cores. Very useful information to get. So this will sort of tell you how the system looks like. But if you want to know what's happening in the program when you execute it, you can use performance counters. And actually, most of the profilers I talked about use performance counters in addition to sampling, like the Intel vTune. So a performance counter is a special purpose processor register that can be programmed to count various events, such as level 1 cache misses, number of floating point operations, and so on. There are a great number of events that can be counted. But however, you only have a small number of these counters, and usually it's below 10, and often it's as low as 4, 2 or 4. These are specific to processor type and vendor, and sometimes tricky to use and understand. You can have overflows of this counting, multiplexing of counters so that they count during a counting session. You can sort of take turns in counting different events, and you can have derived events and so on. PAPI or PAPI is a portable API for using performance counters. It's quite useful. If you're on a Linux computer and have installed support for PAPI, you can find out the available counters by typing PAPI avail, and then you get a list of various counters. And here is an example how it might look like. So we have PAPI L1 DCM. So this is data cache miss on level 1 caches, and you get information, is this a derived counter or not? A derived, if it's not a derived counter, it means that this counter counts actually the number of data cache misses on level 1 cache that happens. But derived counters are sort of calculated, so the information in these counters are calculated from multiple other counters. But have a look at those and see what you can find out. You can, in your code, C code or C++ or others, count events yourself. You don't need to use a tool, external tool, although many external tool uses these counters. So for instance, the start counter and stop counter will sort of count the events that happen between event and counts, and first you tell in the events data structure what counter you want to measure, and then you get the result in the counts array here.